everybody. Hope you're having a good Friday here. Getting geared up for the webcast, and we've got a little bit of cloud material outside. I don't know if you looked at that time-lapse animation, but you could definitely see two different cloud layers. There was one that had some fragments of lower clouds moving more right to left, and then the higher layer was coming straight towards the camera. And the higher layer is kind of like cirrus, and the layer below that is altocumulus at about 15,000. So there's a little bit of mid-level moisture, and we'll do a little bit of isentropic analysis and let you see how that works. And I'm out of LaCroix. I might have to go grab a drink real quick. So give me a second, and here I'll give you a 500 millibar map to look at. Just 1 second, guys. Okay, we're back here, and let's see, let me click one of my buttons, and here I am. So, getting a little bit of that live cam stuff going. We're going to figure out some stuff to do with that. Maybe we can, I don't know, I probably don't want to do like the weatherman and be pointing at the maps or anything like that, but that might be a good way to open the show. But in any case, let's see here. First chart we've got up is going to be, I guess, this temperature anomaly chart here. And we can see we've got northerly flow in Canada, and it's above normal in that area, which is kind of weird. Kind of unusual weather patterns. So we might have had some downslope off the Canadian Rockies. Maybe we had air crossing Alaska very quickly and then coming on the other side. But that is kind of unusual there. Most of the cold air we have in North America is centered on the Great Basin area, right in that area there. So, big ridge out west and trough out east, so that's going to help bring a little bit more of this Canadian air southward. We've got a bit of a trough developing in the southwest U.S. right there. And let's see if we have the high temperatures up. Don't have high temperatures up, so let's take a quick look at the minimum temperatures today. See just how cold it's been lately. And fairly cold across much of the country, teens and 20s in Texas. We had a few freezing temperature readings in the DFW area here. And out east, 10 degrees there at Tonopah, and as I remember from working there, that was very cold for that time of year. So we've got quite a bit of cold air settling in across this area. All right, let me take a quick look at the chat, make sure the audio and everything is running fine. See, we've got our regular crowd here. Tree Nelson, Sue, and Mark and Jeff. Michael was there. Sarah, Alexi, Mark, Andrew, Brian. Three Pistols, that's a new name right there. Yeah, we were going to take a look at Georgia weather, so yeah, we're going to do that here in just a second. I've got Southwest Georgia radar loaded up. Mentioning that was an EF3 tornado. High temperature map, Ron is asking about that. That's coming from the DIFAX archive at Colorado State, and I'll give you the URL here. I think, yeah, you can see that right there. archive.atmos.colorado.state.edu. And these are all National Centers for Environmental Prediction charts. And these are actually legacy charts dating back, a lot of them date back to the 1960s and 70s, actually. These high temperature maps, these were used everywhere in the 70s and 80s for weathercasters to put their high temperature maps together. Most TV stations, they had a big old fax machine, and that's how the maps came in. And I knew some people that actually had a feed in their own house back when the telephone company was regulated and they had to keep the rates down. You could get a feed for like $50 a month and get charts in your very own house back then. Okay, let's see here. Soundings. Probably a representative sounding for our area here would be maybe Shreveport. And you can see an area right there, higher relative humidities up at 14,000 feet, and then here's this other layer of higher humidities. This is up at 26,000 feet here. And you can see this higher layer is moving east-northeast at about almost 100 knots. This other layer is moving a little bit more east-southeast at a slower rate. And so that explains a little bit of what you were seeing there on that time lapse. Okay, I was going to show you a little bit of the isentropic charts, and it would be really good for me to show you the clouds on the satellite imagery. So let me pull that up here. This is the Marshall Space Flight Center. And I'll zoom that in here a little bit. Let me change some values here, get that going. That's probably a little bit too zoomed in. Okay. So here we go. You can see some mid and high cloud over central Texas here. So where's that coming from? We have high pressure across Texas, so we can look to the isentropic charts and see what's going on. This is the isentropic charts from College DuPage. And the way we read this is these black lines, these are the height in millibars. So 700 millibar level, that's going to be about 10,000 feet. So as long as you're close to that line, you're going to be at about 10,000 feet. And then here is 600 millibars. This is up at about 14,000 feet. So this is sloping from lower elevations, about 5,000 feet, up to 15,000 feet in the Midwest. And the reason for that is cold air at the surface. So in a way, this kind of gives you, this is going to kind of correspond fairly closely to the thickness charts. And you can also see there's a wind field showing winds at all of these levels. So in the Midwest here, up at 600 millibars, 14,000 feet, the winds are blowing out of the west-southwest. But near the coast, Gulf Coast out in this area, down at 5,000 feet, winds are blowing out of the northwest. And this is important because if we have winds that are ascending these isentropic surfaces, we're going to have lift. So right here is an area of lift, and also here's an area of high relative humidity in green. So this is actually where we're getting a little bit of cloud forming. And I can go up to a different potential temperature level. If I want to go higher up in the atmosphere, I can go to higher Kelvin values. And that's up here at the top here. So 305, 310 Kelvin, that'll get us way up in the upper part of the troposphere. On the other hand, if I want to go down, I can drop down to 280, 285. But obviously, you can see here, we're intersecting the ground and getting bad data. See, 1,000 millibars, 1,100, that's going to be way underground. So you have to kind of be alert to this when you're using these charts. So pretty much, let's focus on Texas and go to higher isentropic levels. 285, that's going to be just above the surface. And you can see we've got isentropic subsidence in East Texas, except in West Texas we pick up a little bit of lift here. Then 290 takes us up into the mid-troposphere. We're picking up more lift in this area here. And then we go higher and higher. Lots of isentropic lift through that area right there. Now there's another site you can use. This is only an analyzed data. If you want to look at forecast isentropic charts, you have to go to a different website. And this would be Earl Barker's site here at wxcaster.com. Just do a website search for wxcaster and isentropic, and you'll get this interface right here. And I think these are kind of outdated here. ADA, that's no longer running. That's probably NAM data now. So let's do a quick forecast for tomorrow morning. 24 hours from this morning. Okay, so I'll click on that. And then you have to click on these boxes here. And this will give you an isentropic chart. And so you can see the height values here. There's 700 millibars, that's 10,000 feet. So it's showing subsidence there at that level. The only bad thing about Earl's site is we're lacking relative humidity. Mixing ratio doesn't really help you very much. You really need relative humidity. Because if you have values over 70 to 80%, that means clouds. And if you're drier than that, you're not going to get any clouds forming at that level, much less any precipitation. Okay, so that's a quick isentropic lift refresher. And we'll do the Southwest Georgia stuff at the end of the lesson, so let's get through this real quick. 500 millibar forecast showing northwesterly flow coming out of Canada here. There's our trough digging in there in Arizona, and let's see what happens over the next day. We roll that forward and we see the trough move out into Texas, so that's going to bring some lift across the state. Then the trough moves on out towards the southeast U.S., and we come under this strong northwesterly flow over the weekend. Then by Tuesday and Wednesday, we see things becoming more zonal across the U.S. Large trough coming onshore here on the west coast. This is on Friday the 3rd. And then you see that trough moving onshore here. So it looks like some weather probably coming into the Great Plains on February 5th. Here's another trough opening up northwesterly flow again. February 6th and 7th. Then we go zonal again after that. So this is probably a new frontal system coming through the area. So you remember trough, ridge, and then surface system, something like that. So this is on February 9th here. Okay, there's a little bit of that isentropic lift working on the Permian Basin of Texas, around the Concho Valley area, San Angelo. A little bit of showers, and these are going to be kind of high-based showers with kind of an inverted V sounding. By inverted V, something like that right here. So if you precipitate into this, you're precipitating into dry air. You're going to get evaporation and cooling. And you're going to have a lot of virgo with that also. So let's get ready to roll the charts forward, and then we'll get into Georgia's weather. Okay, let me take a look at chat here, make sure everything's looking good here. Michael Burrell discussing the spotting and rescue operations there. Oh, mentioning southern Colorado. Okay. Lloyd's checking in. Okay, yeah, you can definitely catch the archive tomorrow. All right, let's roll the GFS forward, starting with this high pressure across the western U.S. You can see that system down in South Texas kind of moves on off to the east. Lots of cool air across the eastern U.S. You can see the thicknesses are pretty low here. But then we're going to see a warm-up by Sunday. So for Sunday's webcast, there goes that 540 thickness line moving out to the east. And we get a warm-up here in the plains. Some air mass modification going on. And here comes an Alberta clipper through the northern plains. So there's your fronts right there. A little bit of snow with this system. And it looks like the GFS is coming more into line with the Canadian model, bringing that through the Great Lakes region, through Wisconsin and Michigan. So for Tuesday's webcast, looking like this. Going to have a bit of a warm front through this area here in the Central Plains. Then going through to Thursday and Friday, Pacific's starting to get a little active out here. Looks like we bring the Great Plains front a little bit south, developing a little bit of precip with that. Then that high just kind of noses southward over the weekend. And looks like we get a little bit of isentropic lift across that frontal surface as a new system comes through Texas and New Mexico. So GFS going for snow there on Sunday the 5th, 4th through the 5th. And looks like showers for East Texas there on Sunday. So by the 6th, here comes our, looks like a bit of a East Coast system getting started up here in the Carolinas, moving up the coast. And then cold air following behind that on the 7th. Okay, that's probably about as far as I want to go with that chart. And let's take a look at the Georgia storm. This is from the morning of the 22nd. See if I can back this up here. This is the storm we're talking about that affected Cook County, Brooks County. This was responsible for, I believe, 15 deaths along the track. So you can see it at the very beginning here. This is about 3 in the morning. Doesn't look too imposing, really. Doesn't looks definitely like, like a severe storm, but we're marginally seeing reflectivity gradients on the south side, not the classic hook echo here. But if you go to storm relative velocity, you can see there is a circulation in that storm here. So we've got about 36 knots in, 36 out from the radar. And then over here, we've got about 34 coming in. So kind of a broad mesocyclone centered on this area. And then there's the signature right here. That could be a tornado. Let me zoom in on that. So that's kind of a suspect area. What I can do is I can go up to a higher tilt and look for consistency. And I see some higher outbound values right there. So there's that. And we would also look at time consistency. The next frame, yeah, it's still there. So this is probably a tornado on the ground right here. Got 40 knots out, 40 in. That's going to be a tornado right there. Spectrum width showing a little bit of variance in the particle sizes here, so there could be some debris in that. And you can see that's pretty well embedded in the storm right there. This is a 804Z, so this is, I believe, 3:04 in the morning. Catching a lot of people asleep there, unfortunately. And then rolling this forward, let's track the storm. Still looks like a circulation going right here. And still a pretty strong meso in that storm. Then here we can see what looks like maybe a new tornado coming together. Looks like some pretty strong gate-to-gate shear right there. We've got 23 out and 36 in. And this is a pretty good distance from the radar. This is Tallahassee. I tried to get Moody Air Force Base, but there's no data for that, so we're having to use this radar. But center of circulation right here. Let's check that out on the reflectivity, and you can see that's pretty much in the inflow area right here. We'll take a look at some higher tilts here. Looks like we pull up the previous time here. But you see this inflow area right here. And we're going to see that close off as we go higher and higher. Probably a little bit of a beware in here. And then we pick up the overhang right in this area, right over the inflow area. So that's the process of putting the different levels and different scans together. Maybe I can now show you a cross section. Let me try to do that. Data looks very coarse there, so that's not too big of a help. I actually prefer looking at the actual data itself rather than these cross sections. You can see I'm bringing this right through the updraft area, and the beware is not very obvious there. But if I simply go up to higher tilts like this, you can see that close off as you go higher and higher. So it's a little bit more evident there using the horizontal charts. Okay, let's see here. Let me get my cursor back. And let's see what happens to the storm as the hour goes on. Storm continues moving northeast. Still retaining a very good circulation there. Very strong gate-to-gate shear there now. Looks like it's intensified. 33 out and 27 in. This is at 28 past the hour. And storm has a definite HP-ish look to that. So that is quite a mess there. Then the storm continues on, and looks like the circulation kind of dies out here, and something looks like it's reforming in this area here. So maybe a bit of an occlusion process going on. There's the new circulation. So I'm seeing about maybe 70 out and 3 in. Let me check for consistency here. Yeah, definitely seeing consistency there at the higher tilts, and we have time consistency. So that circulation is now set up right there, and we see very strong gate-to-gate shears coming together here. And we are getting pretty far from the radar. This is about 66, 67 miles from the radar. That's getting almost out of range for tornado forecasting, but if I was forecasting this, I would probably start using this other radar up here, JGX. Then let's see what happens for the remainder of the hour. Storm continues moving northeast. And there's that strong circulation right there, so yeah, you definitely want to have your warnings out on that storm. Let me check the comments, see if anybody has anything to say about that Georgia storm. Not really any. Where do you go to get the GR Level 2 files for old events? You can go to, let me give you the source for this. Put in HAS in CDC, and into your search engine. That'll take you to their central data archivals. So you just basically click on radar and go to this downloaded radar site link, and this will take you to this access page here. So if you actually want to bookmark it, there's the address for it. So ncdc.noaa.gov/nextradinv. Then you just basically select which radar you want and your time, and that'll give you the data you can look at. It gives you a choice of level 2 or level 3. And the level 2 data is going to be a lot less messy to work with. Okay, let's see here. Tallahassee, Moody, and Warner Robins radars were all offline at one point that morning. Yeah, it's kind of unfortunate there. Anyway, I think that's about all I got for tonight. Hope you have a good Friday, and we will see you at the usual time tomorrow. Take care, all.